Beneath our modern world lie mysteries that science still cannot fully explain. Ancient structures built with precision we struggle to replicate, technologies lost to time, knowledge that seems impossible for its era, civilizations that vanished without clear explanation. Tonight we journey through genuine archaeological enigmas, verified historical puzzles, and ancient achievements that challenge our understanding. These aren't myths or conspiracy theories. These are real mysteries, documented by scientists, studied by experts, and waiting for answers. Let us explore what the ancients knew, what they built, and what they left behind that we still cannot explain. So, what makes something a genuine scientific mystery? First, it must be real, verified through archaeological evidence and peer-reviewed research. Second, mainstream science must acknowledge uncertainty or debate about it. Third, it should challenge our understanding of ancient capabilities or knowledge. And fourth, multiple competing explanations exist, with none being completely satisfactory. This documentary focuses exclusively on such verified mysteries. We won't discuss ancient aliens, lost Atlantis, or pseudo-archaeological claims. Instead, we'll examine what reputable scientists and archaeologists genuinely struggle to explain. These mysteries are remarkable enough without any embellishment. The real questions are, how did ancient peoples achieve what they did? What knowledge did they possess? And why have some answers been lost to time? Archaeology reconstructs the past from fragments. Ancient peoples left buildings, tools, art, and occasionally writing. But they rarely left behind instruction manuals. We have to infer purpose, method, and meaning from physical remains, and this creates inherent uncertainty. A stone structure might be a temple, an observatory, or a tomb, or maybe all three. Ancient knowledge transmitted orally vanished when cultures disappeared. Technologies that evolved over generations left no user guides. On top of that, time destroys evidence. Organic materials decay. Earthquakes topple buildings. Erosion erases details. What survives represents just a tiny fraction of what once existed. This means some mysteries may be unsolvable, not because explanations are impossible, but because the evidence is simply gone. Understanding this limitation helps distinguish a genuine mystery from a gap in evidence that may someday be filled. We often underestimate ancient peoples. Modern stereotypes can portray them as primitive, lacking sophistication. This is profoundly wrong. Ancient humans had the exact same brain capacity as we do. They were creative, intelligent, and ingenious. Given time, resources, and motivation, they achieved remarkable things. However, some of their achievements seem to require knowledge or technology we don't believe they possessed. And this creates a mystery. Did they develop lost technologies? Did they have knowledge sources now unknown to us? Or do we simply underestimate what's possible with patience, labor, and clever simple tools? Often the mystery isn't that ancient peoples couldn't do something, but that we can't figure out how they did it with the tools and knowledge available to them. This really humbles our modern assumptions that progress is always linear and recent. Most ancient knowledge was transmitted orally. Skilled craftspeople taught apprentices through demonstration. Priests memorized sacred texts. Elders passed down histories through stories. Writing was rare and often reserved for very specific purposes. So when cultures were destroyed, through conquest, disease, or collapse, those oral traditions died with them. This means vast amounts of knowledge simply vanished. We see the results, the incredible buildings, artifacts, and astronomical alignments, but the how-to knowledge is gone. Indigenous peoples today sometimes preserve knowledge their ancestors held for millennia. This shows how effective oral tradition can be, but also how fragile it is. One generation's failure to pass on knowledge can create a permanent loss. Many ancient mysteries likely result from this extinction of oral knowledge. What we call a mystery, they just called common knowledge. Determining when ancient sites were built and used presents its own challenges. Radiocarbon dating works for organic materials up to about 50,000 years old, but stone can't be carbon dated directly. So archaeologists date stone structures by associated organic materials found nearby, like charcoal from fires, wooden tools, or bones. This creates uncertainty. A stone monument might be far older than the datable materials found around it. Different archaeological layers might represent different time periods of use. Sites could have been built, abandoned, reoccupied, and modified over centuries or even millennia. Plus, dating methods have margins of error, sometimes spanning centuries. This chronological uncertainty affects our understanding of ancient capabilities. If a structure is older than we assumed, it pushes back the timelines of technological development. If it's newer, it changes the entire context. Some mysteries persist simply because we're not entirely certain when things actually happened. Experimental archaeology tries to replicate ancient achievements using period-appropriate tools and methods. Researchers will build megalithic structures with stone tools, create ancient alloys in primitive furnaces, and navigate using ancient astronomical knowledge. These experiments sometimes solve mysteries, demonstrating that ancient peoples could achieve what seemed impossible. Other times, the experiments fail, deepening the mysteries by showing that certain explanations just don't work. Importantly, experimental archaeology reveals that ancient methods often differ radically from modern approaches. We use cranes and power tools. They used leverage, ropes, and enormous patience. We calculate with computers. They used observational astronomy and geometric principles. Understanding that different doesn't mean impossible. Helps solve some mysteries while highlighting which ones remain genuinely unexplained. Experimental archaeology humbles our modern assumptions while revealing incredible ancient ingenuity. Some ancient knowledge was preserved through cultural continuity. For example, Egyptian hieroglyphs were decoded because Coptic, a descendant language, survived. Chinese civilization maintained records spanning millennia. However, many cultures experienced catastrophic disruption. The classic Maya collapse ended the transmission of their sophisticated astronomical knowledge. The European conquest of the Americas destroyed Aztec and Inca knowledge systems. The Bronze Age collapse disrupted entire Mediterranean civilizations. These disruptions created huge gaps in our knowledge. We can see their achievements, but we've lost their explanations. Interestingly, some indigenous peoples retain knowledge that archaeologists later validated. Native American oral traditions accurately describe geological events from thousands of years ago. Aboriginal Australian stories encoded environmental changes from the Ice Age. This shows that oral tradition can preserve information across vast timescales when cultural continuity exists. Where that continuity broke, mysteries emerged. Ancient mysteries naturally attract pseudo-archaeological claims. Things like ancient aliens, lost advanced civilizations like Atlantis, or mystical explanations. These claims are popular, but they lack any scientific support. They often disrespect ancient peoples by attributing their incredible achievements to outside intervention rather than human ingenuity. Pseudo-archaeology cherry-picks evidence, ignores contradictions, and presents wild speculation as fact. It damages the public's understanding of genuine archaeology and the real mysteries that exist. This documentary will avoid pseudo-archaeology entirely. Every mystery we discuss is recognized by mainstream archaeology as unexplained or debated. Every fact presented is verified through peer-reviewed research. The real mysteries are fascinating enough without fabrication. Ancient humans were remarkable. They don't need aliens to explain their achievements. By focusing on legitimate scientific questions, we honor both the capabilities of ancient peoples and the integrity of modern archaeology. The truth is always more interesting than fantasy. We will now explore ancient mysteries across continents and millennia, from the oldest known megalithic site to unexplained ancient technologies, from astronomical knowledge that seems impossible for its time to structures that challenge our engineering understanding. From lost writing systems to vanished civilizations, each mystery is real, documented, and debated by experts. Some may have solutions proposed but not yet proven. Others remain completely unexplained. All of them reveal that ancient peoples were far more sophisticated than we commonly believe. Let us begin our journey 11,500 years ago in what is now Turkey, where the oldest mystery of all awaits. Göbekli Tepe, a name you've probably never heard, but one that every archaeologist knows. Deep in southeastern Turkey lies a site that's rewriting human history. Massive stone pillars dating back to 9,500 BCE. That's 11,500 years ago. To put that in perspective, this site is 6,000 years older than Stonehenge and 7,000 years older than the Great Pyramids of Egypt. It predates pottery, writing, and even agriculture by thousands of years. According to everything we thought we knew, Göbekli Tepe shouldn't exist. It was built by hunter-gatherers, people we believed lacked the complex social structure needed for such an undertaking. Yet here it is, forcing us to ask questions we can't yet answer. Believe it or not, when the site was first noted back in 1963, it was dismissed as nothing more than a medieval cemetery. It wasn't until 1994 that a German archaeologist, Klaus Schmidt, saw it for what it truly was. His excavations uncovered massive, T-shaped limestone pillars, some standing over 15 feet tall and weighing up to 10 tons. These were arranged in large circles, and they're covered in sophisticated carvings of animals, lions, foxes, boars, snakes, and birds, alongside mysterious abstract symbols. Ground-penetrating radar has shown there are over 20 of these circles spread across 22 acres, but only a few have been unearthed so far. Schmidt led the work until his death in 2014, and today's archaeologists continue to peel back the layers, revealing more mysteries with every dig. Göbekli Tepe has completely turned our understanding of early human society, religion, and the dawn of civilization on its head. So, how do we know it's really that old? Multiple dating methods all point to the same incredible age. Radiocarbon dating of organic material found within the fill of the structures consistently gives dates around 9500 BCE. Another technique, called optically stimulated luminescence, which dates the last time soil was exposed to sunlight, confirms this time frame. What's truly shocking is the context. This is the oldest known monumental architecture in the world by a staggering margin. The people who built it left behind no pottery, no signs of farming, and no evidence that they lived here permanently. According to the old models, hunter-gatherers were supposed to be small mobile groups, not capable of building monuments. Göbekli Tepe proves that assumption was completely wrong. This means religion might have come before agriculture, complex societies might have formed before farming, and our entire timeline of human development could be flawed. Think about the engineering challenge. How did people with only stone tools quarry, transport, and erect 10-ton pillars? The quarries are nearby, and archaeologists have even found pillars half-carved, still attached to the bedrock. We can see the tool marks left by their stone chisels, but moving these behemoths, some weighing up to 20 tons, over rough terrain is another story. Experiments suggest it would have taken hundreds of people pulling ropes over wooden rollers or sledges. Then they had to raise them upright, probably using earthen ramps, levers, and counterweights. Remember, no metal tools. Everything was done with stone, wood, and rope. The precision is just astounding. The pillars are perfectly vertical, and the carvings show incredible artistic skill. This wasn't a random project. It required leaders, planners, skilled specialists, and a sustained, coordinated effort from a huge workforce. Which leads to the next question. Where did all these workers come from? Building just one of these enclosures would have taken thousands of hours of labor. Hunter-gatherers usually lived in small nomadic bands of 25 to 50 people. Göbekli Tepe clearly required a much larger organized group. The evidence suggests people traveled from all over the region to gather here. Archaeologists have found the bones of thousands of wild animals, like gazelles and aurochs, indicating massive feasts took place. It seems large groups would gather here periodically, maybe for religious festivals. They'd work on the structures, feast together, and then disperse back to their lands. Organizing all this, the labor, the food, the logistics, demands a level of social complexity we never thought possible for hunter-gatherers. They built a complex society without ever planting a single seed. So, what was the purpose of this incredible place? The consensus is that it was a religious sanctuary, a temple complex, but for what kind of religion? The intricate carvings are our only clues. The animals, lions, snakes, foxes, could be totem spirits, powerful deities, or even constellations. Some pillars have human-like arms carved on their sides, suggesting they might represent revered ancestors or gods. There are also geometric symbols that appear again and again, but their meaning is lost to time. No one was buried here, so it wasn't a cemetery. And no one lived here, so it wasn't a town. It seems to have been a pilgrimage center, a shared sacred space where different tribes could come together. It seems the power of belief, not the need for food, was the driving force behind humanity's first great architectural achievement. But here is where the story gets even stranger. After all that effort, Göbekli Tepe was deliberately buried. Around 8000 BCE, after 1500 years of use, the entire site was intentionally backfilled. Tons of soil, rock, and debris were used to completely cover the massive pillars. It wasn't a natural collapse, it was a conscious act. New, smaller structures were sometimes built on top of the buried ones, and then they were buried too. Why would anyone bury their own sacred temples? Maybe their beliefs changed and the old gods had to be put to rest. Perhaps there was social chaos or an environmental disaster. Or maybe the act of building and burying was part of the ritual itself. We simply don't know. The deliberate burial is perhaps the greatest mystery of all. Some researchers believe the site holds another secret, a deep knowledge of the stars. They argue that certain pillars and enclosures align with the solstices or the positions of stars as they would have appeared 11,000 years ago. The animals carved on the pillars, they suggest, might even represent ancient constellations. This idea is still debated. You can find patterns anywhere if you look hard enough, and proving they were intentional is difficult. However, the builders were hunters, and they certainly would have tracked the seasons and the stars for survival. Whether this knowledge was encoded into their monuments is a tantalizing but unproven theory. It remains one of the many open questions that makes Göbekli Tepe so fascinating. The discovery of Göbekli Tepe has completely revolutionized how we see our own past. The old story went like this. First came agriculture, which created food surpluses. That allowed for settled villages, complex societies, and finally grand monuments. Göbekli Tepe flips that script entirely. Here, we have complex society and monumental architecture coming first. It is possible that the need to feed all the workers and pilgrims gathered at these sacred sites is what actually spurred the invention of farming. It suggests that our ideology, our beliefs and rituals, was just as powerful a driver of civilization as economics. It proves that hunter-gatherers were capable of incredible social and artistic achievements, and it's a powerful reminder that there is so much of our own history that is still completely unknown, and so many mysteries remain. Who exactly were these people? What language did they speak? What did the symbols mean? Why did they choose this specific hilltop? And why, after centuries of work, did they bury it all and walk away? We've only excavated about 5% of the site. The other 95% is still underground, holding secrets that might one day give us answers. But archaeology is slow, careful work. It could take another century to fully understand this place. In the meantime, similar, smaller sites are being found nearby, suggesting this wasn't a one-off, but part of a whole forgotten world. The more we learn, the deeper the mystery gets. So, Göbekli Tepe isn't a mystery in the sense that we have no idea what it is. We know who built it, hunter-gatherers of the Stone Age. We know when, around 11,500 years ago. We even have a good idea of how they did it, with clever engineering and sheer manpower. The real mystery is why. We don't understand the beliefs that inspired them, the social leap that allowed it, or the meaning behind their symbols. And we don't know why they so carefully buried their own magnificent creation. Göbekli Tepe is a monument to the incredible ingenuity of our ancient ancestors, and a humbling reminder of just how much about our own story we have yet to discover. From the dawn of monumental architecture, we now travel forward thousands of years to another engineering marvel that continues to baffle experts. The Great Pyramid of Giza, built around 2500 BCE, stands as the pinnacle of ancient Egyptian achievement. But while we know who built it and why, the question of how they achieved such perfection with Bronze Age technology remains one of history's most persistent mysteries. Join us as we examine the secrets of the pyramids. Thank you for Welcome to the Great Pyramid of Giza. Built for Pharaoh Khufu around 2560 BCE, it stands a colossal 480 feet tall, made from about 2.3 million limestone blocks, each averaging 2.5 tons. For 3,800 years, it was the tallest human-made structure on Earth. Its precision is what truly astounds us. The base is level to within 2 centimeters, the sides align almost perfectly with the cardinal directions, and the angles are remarkably consistent. Modern engineers marvel at its construction. How did Bronze Age Egyptians achieve this? Let's establish the facts. The pyramid was built during Egypt's 4th dynasty, around 2560 BCE, as a tomb for Pharaoh Khufu. This is confirmed by quarry marks, graffiti found in internal chambers, and historical context. The core is made of locally quarried limestone. The outer casing, which has been mostly removed, was fine white Tura limestone. The interior contains chambers, passages, and shafts, including the king's chamber with its granite sarcophagus. The workers were not slaves but paid laborers. We know this from discovering their villages, payment records, and even their graffiti. Thousands were involved, perhaps 10 to 20,000, working seasonally when the Nile flooding prevented farming. The entire project took about 20 to 27 years. These are the established facts, accepted by virtually all Egyptologists. The mysteries lie in how they did it, not the who, when, or why. The pyramid's precision is extraordinary. The base, measuring 230 meters per side, is leveled to within just 2.1 centimeters, an error of less than 0.1%. The 4 sides align with the cardinal directions to within 3.4 arc minutes. The 4 base angles are within 2 arc minutes of a perfect 90 degrees. Inside, passages maintain consistent angles over long distances. In the king's chamber, the granite blocks fit together so precisely a credit card won't slip between them. How did workers achieve this with just copper tools, wooden squares, and plumb bobs? Today, we use laser levels and theodolites. The Egyptians used far simpler tools, yet achieved comparable precision. They clearly had sophisticated measurement techniques. We understand some methods, like using water-filled trenches for leveling and astronomical observations for orientation. But the sheer consistency of this precision across the entire structure remains deeply impressive and somewhat mysterious. Where did 2.3 million stone blocks come from, and how were they extracted? The core limestone came from local quarries right next to the pyramid. The finer casing stones came from Tura across the Nile, about 10 kilometers away. Granite for the internal chambers came all the way from Aswan, 800 kilometers to the south. Quarrying limestone with copper chisels and wooden wedges is possible, but it's very labor-intensive. Workers would cut grooves, insert wooden wedges, soak them with water, and let the expansion fracture the stone. But granite is much harder. Copper tools can't cut it. The Egyptians likely used dolerite pounders, extremely hard stone balls, to pulverize the granite. Experiments show this works, but it takes an enormous amount of time and effort. Some blocks show tool marks consistent with these methods. However, the sheer number of blocks, possibly one carved every few minutes for 20 years, challenges our understanding of their logistical capabilities. Transporting millions of blocks, some weighing over 50 tons, posed massive challenges. Limestone from local quarries likely moved on wooden sledges pulled by teams of workers. Pouring sand or water in front reduced the friction. A 2014 discovery showed that wetting sand could dramatically reduce the friction, possibly halving the force required. Blocks from Tura crossed the Nile on boats during the annual flood, when water levels were high. The massive granite beams in the king's chamber, weighing up to 80 tons, came 800 kilometers from Aswan by barge down the Nile. Archaeological evidence confirms these methods. We have sledges depicted in tomb paintings. We've found harbors near the pyramid site, and even grooves in desert rock that match sledge runners. What remains mysterious is the organization, coordinating thousands of workers and managing the logistics of quarrying and transporting simultaneously over decades. This required an administrative capacity that would rival modern large-scale construction projects. How did workers lift blocks to heights of nearly 500 feet? The consensus is ramps, but the exact type is still debated. A straight ramp would be a long, single ramp built from ground level, which would need to be extended as the pyramid rose. But this would require an enormous volume of material and stretch over a mile long to maintain a manageable slope. A spiral ramp would wrap around the pyramid's exterior. This is more compact, but it creates problems at the corners. Then there's the internal ramp theory, proposed by architect Jean-Pierre Houdin, which suggests an internal spiral ramp within the pyramid structure. Other ideas involve using wooden levers to raise blocks incrementally. Each theory has its supporters and its problems. No definitive archaeological evidence of any specific ramp system exists, likely because the ramps were dismantled after construction. The ramp mystery persists. The pyramid's internal structure also raises questions. There are three main chambers: the subterranean chamber cut into bedrock, the so-called Queen's Chamber, and the King's Chamber. Why three? The plans likely changed during construction. The Grand Gallery, a corbelled passage leading to the King's Chamber, is an architectural masterpiece, and its purpose is still debated. 4 small shafts extend from the King's and Queen's chambers. For a century, archaeologists thought these were for ventilation. However, the Queen's chamber shafts were sealed at both ends, ruling that out. Theories now suggest religious purposes, perhaps soul passages for the pharaoh's spirit, or astronomical alignments, possibly pointing to specific stars significant in Egyptian afterlife beliefs. Recent robot explorations of these shafts have revealed mysterious small doors with copper handles. Beyond those doors, more passages. What lies deeper inside remains unknown. The pyramid's apex is incomplete, lacking its capstone or pyramidion. Was it ever placed? And if so, what happened to it? Ancient capstones, called Ben stones, had religious significance and were sometimes gilded or made of precious materials. The Great Pyramid's capstone, if it existed, would have been substantial, possibly weighing several tons. No evidence of it has ever been found. Some theories propose it was never placed, perhaps due to Khufu's death. Others suggest it was made of a valuable material and looted long ago. Its absence creates that iconic flat top, but whether this was intentional or accidental is unknown. The missing capstone symbolizes the larger mysteries of the pyramid. What else is missing or misunderstood? What purposes have been lost to time? The Great Pyramid also seems to encode mathematical relationships, some intentional, others possibly coincidental. The ratio of the pyramid's perimeter to its height is a very close approximation of 2 pi. The pyramid's slope angle, about 51.8 degrees, creates a ratio between its height and base that some claim relates to the golden ratio, phi. Even the pyramid's dimensions have been said to encode Earth's dimensions at scale. Organizing thousands of workers over decades required sophisticated administration. Recent discoveries shed light on this. Worker villages near the pyramid housed laborers. We've found bakeries, breweries, and facilities for fish processing that supplied their food, and medical facilities to treat injuries. There's even evidence of specialized work gangs, with graffiti naming teams like Friends of Khufu and Drunkards of Menkaure, which suggests competition and pride. Papyrus documents discovered at a site called Wadi al-Jarf detail the logistics, including stone transport from Tura. A foreman named Mira kept detailed records of his crew's work. This reveals a bureaucracy with record-keeping, resource allocation, and task specialization. The Egyptians didn't just have engineering skills, they had organizational capacity rivaling modern project management. Modern researchers attempt to replicate pyramid construction using ancient tools and methods. These experiments give us insights, but they have their limits. Small-scale tests have successfully quarried and moved blocks with reconstructed tools. A Nova television experiment in the 1990s moved blocks with teams of workers using wooden sledges. Japanese researchers who attempted to build a small pyramid using only ancient methods struggled with precision and had to give up part-way. These experiments show that individual techniques are feasible, but they can't replicate the full scale, the sustained organization, and the decades-long commitment the original required. Modern workers just don't have the Egyptians' lifetime of specialized experience. Small experiments don't scale linearly to moving 2.3 million blocks. So, while science has explained much about the Great Pyramid, mysteries persist. We don't know exactly which ramp system was used. We can't fully explain how such precision was maintained across millions of blocks and decades of work. We don't know the purpose of all the internal passages. The pyramid was built 4,500 years ago. So much evidence has been lost. What we do know is this: ancient Egyptians, with Bronze Age technology and clever engineering, built one of history's most impressive structures. They possessed a knowledge, skill, and determination we struggle to replicate. The mystery isn't supernatural. It's a testament to human capability operating at its absolute peak. From Egypt's stone monuments, we travel to Peru, where different ancient peoples carved and placed stones so precisely that even today, we cannot insert a blade between them. Sacsayhuamán and other megalithic sites in the Andes demonstrate a mastery of stoneworking that rivals or even exceeds Egyptian achievements. How did the Inca, and the cultures before them, achieve such impossible precision? High in the Peruvian Andes, overlooking the ancient city of Cusco, stands Sacsayhuamán. Massive stone walls comprised of blocks weighing up to 200 tons, fitted together with such precision that a knife blade cannot be inserted between them. No mortar binds these stones, yet they've survived 5 centuries of earthquakes that destroyed Spanish colonial buildings. The Inca claimed they didn't build these walls, that they inherited them from earlier peoples. Modern engineers cannot explain how these blocks were shaped, moved, and fitted with Bronze Age tools. This is megalithic engineering at its most mysterious. Sacsayhuamán's largest stone weighs approximately 200 tons, 400,000 pounds. This is heavier than most of the Great Pyramid's blocks. The walls comprise 3 tiers of zigzag ramparts extending over 1,000 feet. Individual blocks are irregular polygons, each unique in shape yet fitting perfectly with its neighbors. Some blocks have over a dozen angles, matching precisely with surrounding stones. The quarry lies miles away across difficult terrain. How did builders transport stones weighing as much as a Boeing 747? How did they shape irregular polygons so precisely? How did they position 200-ton blocks with millimeter precision? Modern construction equipment would struggle with stones this size. The Inca had no wheels, no iron tools, and no draft animals larger than llamas. Yet they, or their predecessors, achieved this impossible feat. The polygonal masonry technique, irregular multi-sided blocks fitting perfectly, is architecturally and engineering-wise more difficult than using rectangular blocks. So why use it? Theories abound. The irregular shapes might distribute earthquake forces better, preventing catastrophic failure. The technique might allow for the efficient use of oddly shaped quarry blocks without waste. Some researchers even propose the shapes had aesthetic or symbolic purposes, with each unique stone creating organic flowing patterns. But shaping stones to fit this precisely requires either carving each one to fit after positioning its neighbor, which seems impossible with such massive weights, or incredible pre-planning. Neither explanation is fully satisfactory. Modern stonemasons attempting to replicate the technique struggle even with power tools and cranes. The precision suggests knowledge we just don't possess or understand. The Inca had bronze tools, hammerstones, and remarkable patience, but bronze cannot effectively cut or shape andesite and diorite, the igneous rocks used in Sacsayhuamán's finest masonry. These rocks rank a 6 to 7 on the Mohs hardness scale. Bronze ranks a 3. Archaeologists have found hammerstones at these sites, suggesting pecking and pounding methods. Experimental archaeology shows that stone hammers can shape igneous rock through patient pounding, but this requires enormous amounts of time, possibly hundreds of hours per block. For the millions of precisely fitted stones across numerous sites, the time investment seems astronomical. Some researchers propose lost techniques, perhaps using plant acids to soften stone, or even sound resonance to break it along desired lines. These theories lack evidence, but attempt to explain how such precision was achieved with the available tools. Transporting 200-ton stones across mountainous terrain defies easy explanation. Spanish chroniclers recorded Inca stories of moving large stones with thousands of workers pulling on ropes. One account mentions 20,000 men moving a single large stone, a task that took weeks and resulted in deaths when ropes broke. Archaeological evidence shows ramps, earthen platforms, and possible log rollers. The Inca had sophisticated rope technology, creating cables from plant fibers strong enough to support entire suspension bridges. Physics says rope and human power alone could move such masses, but the logistics, coordinating thousands of workers and moving stones uphill over rough terrain. remain difficult to comprehend. Some blocks at Sacsayhuamán show protrusions and knobs, possibly for attaching ropes or leverage. Yet the practical engineering of moving these specific massive stones has never been satisfactorily reconstructed. The Inca themselves actually attributed the finest megalithic walls to earlier cultures. Spanish chroniclers recorded Inca statements that the massive stones were placed by giants or gods in ancient times, long before the Inca Empire. Archaeological evidence supports multi-phase construction. At many sites, including Sacsayhuamán, different masonry styles are evident. Massive, irregular polygonal blocks at the base, with smaller, more regular stones above. Carbon dating and ceramic evidence suggest some foundations predate the Inca by centuries, possibly built by the Quilque or earlier Wari civilizations. The Inca might have simply built upon structures they inherited. This raises more questions. Who were the original builders? Did they possess knowledge the Inca lost or never fully understood? The cultural continuity and disruption in the Andes created layers of mystery. Cusco lies in a seismically active zone. Earthquakes have struck repeatedly over centuries, and while Spanish colonial buildings suffered severe damage, Sacsayhuamán and other megalithic Inca walls remain standing, virtually undamaged. This mortarless construction apparently provides incredible earthquake resistance. The tight-fitting stones can shift slightly during earthquakes, absorbing and distributing energy, then settle back into place. This is called the dancing stones principle. The irregular shapes interlock in 3 dimensions, creating a stability beyond what mortar provides. Modern seismic engineering recognizes this as sophisticated design. Recent earthquakes, including a significant one in 1950, validated the wall's durability. This suggests the builders understood principles of seismic design that modern science is only now validating. How they achieved this understanding remains unclear. And Sacsayhuamán isn't unique. Similar megalithic construction appears across the Andes. Ollantaytambo features massive stone terraces with precisely fitted blocks weighing over 50 tons. Pumapunku in Bolivia contains stones with machine-like precision, perfectly flat surfaces, precise 90-degree angles and complex interlocking shapes. Cusco's streets incorporate megalithic walls into building foundations, including the famous 12-angled stone. This suggests megalithic construction wasn't limited to one site, but represented a sustained cultural tradition spanning centuries and multiple cultures. The widespread nature of these constructions just deepens the mystery. How was this knowledge transmitted, and what motivated such an enormous investment in precision stonework? Modern researchers have attempted to replicate these Andean megalithic techniques with mixed results. A team in Cusco succeeded in moving moderate-sized blocks using reconstructed Inca tools and methods, but shaping stones to fit precisely proved enormously time-consuming and produced less accurate results than the ancient examples. 3D scanning of existing walls reveals precision often within 1 millimeter, remarkable for any era. Some researchers propose the stones were carved in place, while others suggest a sophisticated use of templates we don't understand. The fact is, even with modern machinery, we struggle to replicate this precision. These experiments prove the ancient builders had skills exceeding our assumptions, not that they possessed impossible tools. Tragically, Spanish conquistadors partially dismantled Sacsayhuamán, using its stones to build colonial Cusco. Much of the original complex was destroyed. What we see today represents perhaps only 20% of the original construction. This destruction eliminated evidence that might have helped explain the construction methods. It was an act of cultural vandalism, the systematic destruction of indigenous knowledge and achievement. The irony is bitter. Spanish colonizers destroyed superior engineering to build inferior structures. What knowledge died with the destruction? What inscriptions or details that might have explained the mysteries were lost forever? The conquest didn't just destroy stones, it destroyed the living tradition of the people who understood these structures. Like many ancient structures, Sacsayhuamán shows possible astronomical alignments. Certain walls align with the solstices, and specific features correspond to mountaintop positions significant in Inca cosmology. The Inca were sophisticated astronomers, tracking solar and lunar cycles for agriculture and ceremony. Cusco itself was designed as a cosmological diagram. Sacsayhuamán was integrated into this system, likely serving multiple purposes: fortress, temple, and astronomical observatory. The integration of practical, religious, and astronomical functions characterizes Andean architecture, and modern understanding often struggles to separate these interwoven purposes. Despite extensive research, core mysteries remain. How were 200-ton stones shaped with Bronze Age tools? How were they transported across mountain terrain? How was millimeter precision achieved? The answers likely involve patient labor, clever techniques, and sophisticated organization, but the specifics elude us. Sacsayhuamán stands as a testament to human ingenuity. The mystery isn't that ancient peoples couldn't build it. They clearly could. The mystery is that we, with all our technology, struggle to understand how. That humility is valuable. Ancient achievement deserves our respect and honest acknowledgement of what we don't yet comprehend. From megalithic stone mysteries, we shift to a different type of ancient enigma: sophisticated mechanical technology that shouldn't exist. In 1901, divers recovered corroded bronze fragments from an ancient shipwreck off the Greek island of Antikythera. When researchers X-rayed the fragments, they found something impossible: a complex geared mechanism from the 2nd century BCE, 2,000 years before such technology was thought to exist. The Antikythera mechanism rewrote our understanding of ancient Greek engineering. Let's explore this device that shouldn't exist. The Antikythera mechanism. It's been called the world's first computer. Discovered in a Roman-era shipwreck dating back to around 70 BCE, this bronze device holds over 30 interconnected gears that calculate astronomical positions and eclipses. It represents a level of mechanical genius not seen again for over 1,000 years. Its very existence shatters our assumptions about ancient technology. How did the ancient Greeks build such a complex device? Why is it the only one we've ever found? And what other incredible technologies have been lost to the sands of time? In the year 1900, a group of sponge divers working off the Greek island of Antikythera stumbled upon an ancient shipwreck. It was filled with treasures, bronze and marble statues, jewelry, and pottery. But among the artifacts was a corroded, unassuming lump of bronze that soon broke into pieces. It was initially dismissed as junk and sat in the Athens Archaeological Museum for months. Then, an archaeologist named Valerios Stais noticed something incredible: a gear wheel embedded in one of the fragments. This was shocking. Complex gearing in a 2,000-year-old artifact seemed utterly impossible. Over the decades, researchers slowly began to understand the object's true importance. X-rays in the 1970s revealed its hidden complexity: dozens of gears, detailed inscriptions, and intricate mechanical parts. By the 1990s, using advanced imaging, scientists could read invisible text and map out the entire gear system. The mechanism's sophistication was beyond anything known from antiquity. It was a technological achievement that just shouldn't have existed for its time. So what does this ancient computer actually do? The Antikythera mechanism is an analog calculator for the cosmos. You'd turn a hand crank, and a system of gears would rotate a series of dials, showing you everything from the position of the sun and moon in the zodiac to the current lunar phase. It even tracked the 5 planets known to the ancient Greeks: Mercury, Venus, Mars, Jupiter, and Saturn. Remarkably, it could predict the dates of solar and lunar eclipses and even forecast the 4-year cycle of the Olympic Games. The mechanism incorporated highly advanced astronomical knowledge, like the 19-year Metonic cycle for moon phases and the 18-year Saros cycle for predicting eclipses. Its precision was astounding. It was essentially a mechanical planetarium and an astronomical almanac rolled into one. No other device like it has ever been found. It stands completely alone, a silent testament to a lost age of technological brilliance. The engineering behind this device is mind-boggling. The mechanism contains at least 30 bronze gears, and there were likely more in the sections that were lost. These weren't just simple gears either. They included advanced features like differential gearing, which wouldn't be seen again until the 16th century, as well as complex pin and slot systems to model the irregular movements of celestial bodies. The craftsmanship is extraordinary. The gear teeth were precisely cut, all by hand. The whole device was packed into a compact box about the size of a shoebox, maximizing its functionality. This reveals a deep understanding of gear mathematics and mechanical design. Clearly, the ancient Greeks had the theoretical and practical knowledge to create such machines. But if that's true, where are all the others? The Antikythera mechanism transforms from a technological marvel into one of history's greatest mysteries. Etched into the mechanism's bronze plates are over 3,000 characters of ancient Greek text. This is essentially the device's instruction manual, explaining its operation and the astronomical theories behind it. The text references Babylonian astronomy and Greek mathematical traditions. Analysis of these inscriptions suggests the mechanism was built between 150 and 100 BCE, possibly on the island of Rhodes, which was a hub of ancient astronomy and mechanics. The great inventor Archimedes, who lived a century earlier, was said to have created similar devices, though none have survived. The philosopher Cicero even described seeing mechanical planetariums in Rome. These texts suggest there was a whole tradition of mechanical astronomy that is now lost. So the Antikythera mechanism isn't an anomaly in ancient literature. It's an anomaly in archaeological preservation. Most bronze objects were simply melted down and reused. This one only survived because it was lost in a shipwreck. The ancient Greeks possessed a surprisingly sophisticated understanding of the cosmos. Aristarchus proposed a sun-centered model of the solar system way back in the 3rd century BCE, 1700 years before Copernicus. Eratosthenes calculated the Earth's circumference with incredible accuracy. Hipparchus discovered the precession of the equinoxes and created a catalogue of over 800 stars. While their overall model was geocentric, with the Earth at the center, their mathematical science was incredibly advanced. The Antikythera mechanism perfectly reflects this, combining a geocentric view with precise Babylonian data and Greek mathematical theory. It proves that ancient science could be highly sophisticated, even when its underlying cosmology was incorrect. The device provides physical, tangible evidence for the astronomical achievements that we previously only knew about from ancient writings. The sheer sophistication of the Antikythera mechanism creates a huge technological gap in the historical record. Nothing even remotely comparable appears for over 1,000 years. European clockmakers in the 14th century finally developed astronomical clocks with similar functions, but their mechanisms were far cruder. While Islamic engineers created beautiful astrolabes and mechanical calendars, they were simpler than this ancient Greek computer. So was complex gearing common in antiquity, with most examples simply lost to recycling? Or was the Antikythera mechanism a one-of-a-kind masterpiece? The Roman Empire had impressive technology, aqueducts, concrete, massive structures, but apparently not this kind of intricate gearing. Why did this technology just disappear? Economic collapse and the loss of knowledge during the early Middle Ages are likely culprits. But the mechanism proves that technological progress isn't a straight line. Incredible achievements can be lost only to be rediscovered centuries later. Over the years, researchers have built multiple reconstructions of the mechanism. Early attempts gave us a basic understanding, but in 2006, an international team used advanced X-ray technology to create the most complete analysis yet. Researchers like Michael Wright and Tony Freeth built working replicas, proving that the device functioned just as they thought. These reconstructions required modern precision tools, which raises the question of how ancient craftspeople achieved such accuracy with just hand tools. And there are still gaps in our knowledge. About 30% of the mechanism is missing, corroded and lost to the sea, so any reconstruction involves some educated guesswork. Despite that, the replicas work, validating our interpretations and allowing us to see this ancient marvel in action, appreciating the genius of its creators. So who made it? The creator's name remains a mystery. The style of the inscriptions points to the island of Rhodes as the likely place of manufacture. Rhodes was home to the renowned astronomer Hipparchus, and his calculations align perfectly with the mechanism's functions. Some speculate Hipparchus himself designed it, though there's no direct proof. Another candidate is Posidonius, a famous scholar who, according to Cicero, created similar devices on roads. But it was more likely the product of a specialized workshop with knowledge passed down through generations of masters. The shipwreck was traveling from the eastern Mediterranean towards Rome, carrying a cargo of luxury goods. The mechanism might have been a high-end item for a wealthy Roman patron fascinated by the stars. Its creator surely never imagined their masterpiece would become one of archaeology's greatest enigmas. The Antikythera mechanism suggests that other incredible technologies existed in the ancient world, but left no trace. Ancient texts describe automatic theaters, steam-powered gadgets by Hero of Alexandria, and elaborate mechanical puppets. The Roman writer Vitruvius described mechanical odometers for measuring distances. These accounts were often dismissed as exaggerations, but after the discovery of the mechanism, they seem far more credible. If complex gearing existed, other sophisticated machines probably did too. Most ancient mechanisms were made of bronze, a valuable metal that was constantly recycled. Iron rusts away, and wood decays. The survival of any ancient machine is a miracle. The Antikythera mechanism only survived because a shipwreck buried it in seabed sediment, protecting it from total decay. This means the archaeological record gives us a skewed, incomplete picture of ancient capabilities. We're seeing the exception, not the rule. How many other technologies are now completely lost to time? Despite decades of intense research, many mysteries remain. How exactly were those gears cut with such precision using only hand tools? Was the Antikythera mechanism a unique masterpiece, or were there others like it? If it was part of a tradition, why haven't we found any other examples? And why didn't the Romans who conquered Greece continue to develop this technology? The inscriptions mention a manufacturer, but the name is partially lost and can't be read. How was it used? As a teaching tool, a status symbol, or a practical instrument for astronomers? Perhaps the most profound question is, what other ancient technologies have vanished without a trace, leaving our understanding of the past incomplete? The Antikythera mechanism is a stunning window into a lost world of mechanical genius. What else was in that world? Ultimately, the Antikythera mechanism teaches us a critical lesson. What survives in the archaeological record is not a fair representation of what once existed. Preservation is accidental. If that shipwreck hadn't sunk right there, if the conditions hadn't been just right, if those divers hadn't found it, we would never know the ancient Greeks could build something so extraordinary. It humbles our assumptions about the past and reminds us that an absence of evidence is not evidence of absence. The ancients were capable of so much more than the surviving fragments suggest. This single artifact rewrote a chapter of human history. What else is out there, waiting to be discovered, or is already lost forever? From precise mechanisms hidden beneath the waves, we now turn to massive mysteries drawn across the desert floor. The Nazca lines of Peru, enormous geoglyphs, some stretching for miles, that are only visible from the sky. They were created by a people who never flew. Giant hummingbirds, spiders, monkeys, and strange geometric shapes cover the landscape. Why were they made? How were they designed with such accuracy? In the arid coastal plain of southern Peru, an ancient mystery is etched into the very earth. The Nazca lines stretch across nearly 200 square miles of desert, a breathtaking gallery of geoglyphs created between 500 BCE and 500 CE. We see over 70 figures of animals and plants, 300 geometric forms, and 800 straight lines, some extending an astonishing 30 miles. They were made by simply removing reddish pebbles to reveal the lighter soil beneath. But here's the catch. These massive designs are only fully visible from the air. This raises the central question. Why would an ancient culture create art they themselves could never see in its entirety? What was their purpose? And how did they achieve this without an aerial perspective? Creating the Nazca lines was, technically speaking, straightforward but incredibly labor-intensive. The desert surface is coated in reddish-brown iron oxide pebbles. Underneath, the soil is much lighter. The Nazca people simply removed these surface pebbles along pre-planned lines, piling them to the sides to create contrasting trenches that form the designs. And how have they survived for 2,000 years? The climate is the secret. This is one of the driest places on Earth, with less than an inch of rain a year, and the still air means wind rarely disturbs the shallow carvings. Experiments have shown that small teams could create even the largest figures in a matter of days or weeks using simple tools. So the mystery isn't how they were made, but why they were made, and how such precision was achieved on such a massive scale. The method is known, the motivation remains an enigma. Among the most famous Nazca lines are the dozens of recognizable figures. The hummingbird measures over 300 feet long, the spider spans 150 feet, and the condor has a wingspan of over 400 feet. There's a monkey, a pelican, an orca, and a dog, each drawn with a single, continuous, unbroken line, as if the artist never lifted their hand. We also find plant designs, a strange figure dubbed the astronaut, and various abstract shapes. These figures are stylized but recognizable, and they match designs found on Nazca pottery from the same era. This suggests they were culturally significant symbols, possibly religious or cosmological. But since the Nazca culture left no written records, their specific meanings are lost to time. We can see the incredible art, but we can't read its message. Beyond the animal figures lie hundreds of geometric designs, massive trapezoids, rectangles, triangles, and spirals, some stretching for thousands of feet. Perfectly straight lines crisscross the landscape for miles, running over mountains and valleys. Some of these lines converge at points called ray centers. These geometric forms actually outnumber the animal figures and cover a much larger area, making their purpose even more mysterious. Were they pathways for ceremonial processions, astronomical markers, or maybe territorial boundaries? The precision suggests advanced surveying knowledge. Some researchers believe the trapezoids resemble ancient Andean ritual spaces. The straight lines might connect sacred sites or even point to water sources in the mountains, a crucial element for a culture surviving in such an arid land. So, how did the Nazca people design figures that are best viewed from the sky when they obviously couldn't fly? Well, this question makes a few assumptions. First, many of the figures are actually visible from the surrounding hills and mountains. Second, it's highly likely they created smaller scale designs on pottery or textiles and then enlarged them on the desert floor using simple surveying tools like ropes and stakes. Think about it like this. The builders of great cathedrals couldn't see their creations from above, but they designed and built them successfully. Modern experiments have proven that small teams using basic geometry can accurately recreate these massive geoglyphs. The idea that you need to fly to create them is a modern misconception. They required careful planning and systematic execution, skills the ancient Nazca people clearly possessed. One of the more popular fringe theories is that the Nazca people actually invented hot air balloons to view their work from above. Proponents point to certain ceramic designs that could be interpreted as balloons and textiles woven so tightly they could hold hot air. In fact, in the 1970s, a team built a balloon using only materials and techniques available to the Nazca and successfully flew it. While this showed it was technically possible, mainstream archaeology rejects the theory. Why? There's simply no physical evidence, no remains of balloons, burners, or baskets. And as we just discussed, you don't need an aerial view to create the lines, which removes the main motivation for developing flight. The balloon theory is creative, but it's a case of seeking an extraordinary explanation when an ordinary one works just fine. So what do most archaeologists believe? The leading theories center on religious and ceremonial purposes. The figures might represent deities or sacred animals. The lines themselves could have been ritual pathways walked during ceremonies to honor the gods and ask for rain and fertility. It's possible that different clans or communities were each responsible for creating a figure as a form of ritual labor. This is supported by the discovery of ceramic offerings and other ritual deposits found near some of the lines. The sheer amount of effort involved tells us these geoglyphs held profound cultural importance. In a society without writing, monumental art like this can serve as a cultural text, encoding beliefs and values for the gods above, if not for human eyes on the ground. Another prominent theory, championed by the researcher Maria Reiche, who dedicated her life to the lines, is that they served an astronomical purpose. Some lines do align with the sun's position during the solstices or point toward the rising of certain constellations, as they appeared 2,000 years ago. We know Andean cultures were skilled astronomers, using the stars for agriculture and ceremony. So could the Nazca lines be a giant astronomical calendar? While some alignments exist, further studies have shown they aren't much more frequent than what you'd expect by pure chance. With hundreds of lines pointing in every direction, some are bound to line up with something. Today, most experts doubt this was their primary purpose, though astronomy might have played a secondary role. A more recent and compelling theory connects the Nazca lines directly to water. Survival in this extremely dry region depended entirely on water management. Intriguingly, many of the lines point directly toward water sources in the mountains or correspond with underground water channels. Some researchers propose the lines were ceremonial pathways walked during rituals to request rain from water deities. In Andean cultures, water has always been linked to life and fertility. The Nazca even built sophisticated underground aqueducts called puquios to access groundwater, and some of these align with the geoglyphs. This water-centered theory neatly ties together environmental, archaeological, and anthropological evidence. The lines might have been massive, elaborate prayers for water, etched into the earth itself. For 2 millennia, the desert's dry, stable climate protected the Nazca lines. Today, however, they face modern threats. Off-road vehicles have scarred the delicate landscape, and urban sprawl encroaches on the site. Back in 2014, a publicity stunt by Greenpeace activists left damaging footprints near the iconic hummingbird figure, causing an international incident. The Peruvian government is struggling to balance tourism with preservation. While aerial tours allow people to see the lines without touching them, the vastness of this UNESCO World Heritage Site makes it incredibly difficult to monitor. And now, climate change threatens to bring more rain, which could quickly erode these ancient drawings. It's a tragic irony that these lines survived 2,000 years of nature, only to be threatened by human activity in a matter of decades. While they are the most famous, the Nazca lines are not entirely unique. Similar giant ground drawings or geoglyphs can be found all over the world. In Chile's Atacama Desert, there are thousands of figures. In the American Southwest, Native American cultures created large ground figures called intaglios. And in England, you have the famous chalk hill figures. These examples suggest that creating large-scale ground art is a widespread human impulse, likely tied to religion, territory, or mapping the cosmos. The fact that they appear globally suggests different cultures developed the idea independently. The Nazca lines are simply the most spectacular and best preserved example of this ancient practice, giving us a window into a common human tradition. So, after all this, what do we actually know? We know the Nazca lines were created between 500 BCE and 500 CE by the Nazca culture. We know how they were made, by clearing away the dark surface stones. And we know they are connected to Nazca art found on their pottery and textiles. What we don't know for sure is why. The most likely explanations involve a combination of religion, ceremony, astronomy, and water rituals. But without written records, any interpretation is ultimately an educated guess. The lines may have had multiple purposes that changed over the 1,000 years they were being created. The mystery isn't completely unsolved, but a full understanding is likely lost to time. The Nazca lines will probably always remain an ancient voice we can see, but can never fully hear. From the desert plains of Peru, we now travel to the green fields of England to Salisbury Plain. Here, a circle of massive standing stones forms Britain's most iconic ancient monument, Stonehenge. Built in stages over 1,500 years, it's a masterpiece of engineering and astronomical knowledge. Yet its fundamental questions remain. Why was it built? How were the stones moved? And what purpose did it serve? Stonehenge, perhaps the world's most famous prehistoric monument. Located in Wiltshire, England, this circular arrangement of massive standing stones has inspired wonder for millennia. Built in stages beginning around 3000 BCE and concluding around 1500 BCE, Stonehenge represents 1,500 years of construction, modification, and use. The monument includes two types of stones, massive sarsen stones weighing up to 30 tons and smaller blue stones weighing up to 4 tons. The precision of construction, the astronomical alignments and the sheer effort required make Stonehenge an engineering marvel, but its purpose remains debated. Temple, observatory, healing center, burial ground, perhaps all of these. The stones stand silent, guarding their ancient secrets. Stonehenge was built in 3 major phases over 15 centuries. Phase 1, around 3000 BCE, consisted of a circular earthwork bank and ditch with wooden structures or posts in the interior. Phase 2, around 2900 BCE, saw the erection of the bluestones transported from Wales 240 kilometers away. Phase 3, beginning around 2500 BCE, brought the massive sarsen stones from Marlborough Downs, 30 kilometers distant. These were arranged in the iconic circle with lintel stones on top, plus the interior horseshoe arrangement. The multi-phase construction indicates changing purposes or that knowledge was passed across generations. Each phase required enormous labor. This monument wasn't conceived as a single project, but evolved over a millennium and a half. The bluestones present Stonehenge's most perplexing logistical mystery. These dolerite and rhyolite stones, weighing up to 4 tons each, came from the Preseli Hills in Wales, 240 kilometers away. How and why did Neolithic people transport them such distances? Possible routes include overland sledges, then river and sea transport using boats and rafts, and then overland again. Experimental archaeology suggests this is feasible, but extraordinarily difficult, requiring hundreds of workers and years of effort. Another theory proposes the stones were transported by glaciers during the Ice Age. Most archaeologists reject this, noting that glaciation patterns don't support bluestones reaching Wiltshire naturally. The critical question is why? Were these specific stones considered sacred, possessing religious or healing properties? The enormous effort suggests a profound cultural motivation. The sarsen stones are even more massive. The largest weighs approximately 30 tons. They came from Marlborough Downs, 30 kilometers away. Moving them required sledges pulled by hundreds of workers using ropes, but erecting them vertically presented enormous challenges. Archaeologists believe the builders dug pits, used timber ramps and levers to position stones, then pulled them upright using ropes and counterweights. The lintels, the horizontal stones on top, required additional ingenuity. They were raised using timber scaffolding or earthen ramps, then positioned using mortise and tenon joints, sophisticated carpentry techniques applied to stone. The precision is remarkable. This required skilled craftspeople, engineering knowledge, and amazing organizational capacity. Stonehenge wasn't just a crude piling of rocks, it was sophisticated architecture executed in stone. Stonehenge's most famous feature is its alignment with the solstices. On the summer solstice, the rising sun aligns with the heel stone. On the winter solstice, the sunset aligns similarly. These alignments are deliberate, not coincidental. Neolithic peoples tracked solar cycles for agricultural timing. Stonehenge might have functioned as a solar calendar, marking important dates for planting, harvest, and ceremonies. Some researchers propose more complex astronomical functions, like tracking lunar cycles or predicting eclipses, but these interpretations are controversial. While basic solar alignments are undeniable, claims of a complex astronomical calculator exceed the available evidence. Astronomical observation was clearly part of Stonehenge's purpose, but how sophisticated that observation was remains debated. Stonehenge also served as a burial ground. Cremated human remains of about 64 individuals have been found, dating across the monument's use period. These were deliberate interments of selected individuals, possibly religious leaders or elites. Some remains show evidence of illness or injury, leading to theories that Stonehenge was a healing sanctuary where sick people came seeking cures, and when healing failed, were buried there. The nearby Durrington Wall settlement housed thousands of people seasonally, perhaps pilgrims attending ceremonies. Stonehenge was a cemetery, but also something more, a ritual center where the living honored the dead, celebrated seasonal cycles, and connected with the cosmos. The burials indicate it was sacred ground. Recent research explores Stonehenge's acoustic properties. Sound experiments suggest the stone circle creates unique effects, reflecting and amplifying sounds in specific ways. Bluestones, in particular, produce musical tones when struck. They're called ringing stones. Some researchers propose that sound and music played roles in ceremonies, with the stones functioning as a kind of architectural instrument. The placement of stones could enhance speech, making a speaker inside the circle audible to crowds outside. This acoustic engineering, whether intentional or a fortunate accident, would have impressed participants, adding to the site's mystical atmosphere. However, this theory is speculative. Still, the stones do have unique acoustic properties, which ancient users would have noticed and possibly utilized. Stonehenge isn't isolated, it's part of a broader ritual landscape. Within a few kilometers lie numerous other Neolithic monuments: Woodhenge, a circular timber structure; Durrington Walls, a massive henge enclosure; the Avenue, a processional pathway connecting Stonehenge to the River Avon; and hundreds of burial mounds. This landscape was sacred territory, used ceremonially for millennia. Stonehenge was the central monument in a complex of ritual sites. People came from across Britain, as evidenced by analysis of buried individuals' teeth. Stonehenge wasn't just a local monument, it was a regional or even national pilgrimage center. Understanding Stonehenge requires understanding its landscape context. The stones were the centerpiece, but the wider landscape participated in rituals we can only imagine. Around 1500 BCE, Stonehenge was abandoned. Activity ceased and the monument entered 3,000 years of silence. Why? The Bronze Age brought cultural changes. New religious practices may have superseded Stonehenge's functions. Social upheavals could have displaced the communities maintaining it, or perhaps the meaning simply faded as generations passed. This abandonment erased the oral traditions that explained its purpose, creating the mystery that persists today. Later peoples, Romans, Saxons, Normans, viewed Stonehenge with wonder but had no idea who built it or why. Medieval legends attributed it to Merlin's magic. Only modern archaeology has recovered fragments of the truth, but the complete story remains elusive, because the builders' own explanations died with them. Modern interpretations of Stonehenge vary. Some see it as a sophisticated observatory. Others focus on religious and ceremonial purposes, interpreting it as a temple. The healing sanctuary theory proposes it was a prehistoric lord's. Some view it primarily as a burial ground for elite families. Recent theories emphasize community identity, suggesting Stonehenge was a unifying monument. Most likely, Stonehenge served multiple purposes simultaneously: observatory, temple, burial ground, healing center, and community gathering place. Attempting to identify a single purpose may be misguided. Ancient monuments often had layered meanings. Stonehenge was complex because the society that built it was complex. Despite centuries of study, fundamental questions remain. Why were bluestones brought all the way from Wales? What religious beliefs motivated 15 centuries of construction? What ceremonies occurred there? What did the stones mean to the people who built them? The archaeological evidence provides physical facts, dates, stone types, burial remains, but it cannot recover meaning, belief, or experience. We see Stonehenge through modern eyes, imposing our interpretations on ancient stones. The builder's perspective is irretrievably lost. This gap between physical evidence and cultural meaning defines the mystery. We can study the stones but cannot fully know the people who moved them. Stonehenge endures as one of humanity's most recognizable ancient monuments. It's a UNESCO World Heritage Site, visited by millions. Yet it faces modern challenges: tourist impact, infrastructure development, and climate change. English Heritage manages the site, balancing access with preservation. The iconic image symbolizes human aspiration and our connection to the past. Stonehenge reminds us that our ancestors were capable of remarkable achievements, motivated by beliefs we can only glimpse. Its greatest mystery may be this: it proves that meaning powerful enough to inspire 15 centuries of labor can be completely lost. From physical monuments whose purposes we cannot fully decode, we turn to a written text whose meaning no one can read. The Voynich Manuscript, a 15th century book filled with strange illustrations and written in an unknown script, has defied every attempt at translation. It's been studied by cryptographers and codebreakers for a century. None have succeeded. Is it a hoax, an unknown language, or an unbreakable cipher? Let us examine history's most mysterious book, the Voynich manuscript. Imagine a book, 240 pages of elegant, flowing handwriting, but written in a language no one on Earth can read. It's filled with bizarre illustrations, plants that don't exist, naked women bathing in strange green liquid, and mysterious astronomical charts. Created in the early 15th century, this book has stumped everyone for over 100 years. The same code breakers who cracked Nazi ciphers? They couldn't make sense of it. Supercomputers find language-like patterns but pull out zero meaning. Is this book a lost treasure of ancient wisdom, or is it just beautifully written nonsense? A complex code or an elaborate hoax? Let's dive into one of history's greatest intellectual puzzles. The manuscript's modern story starts in 1912. A book dealer named Wilfrid Voynich found it at a Jesuit college in Italy. Tucked inside was a letter from 1666, claiming the book once belonged to Emperor Rudolph II, who thought it was written by the famous 13th century philosopher Roger Bacon. But that's just a clue. Carbon dating places the book's creation between 1404 and 1438. The style of the art points to northern Italy. But who actually wrote it? We have no idea. Over the centuries, it was passed between collectors, always treated as something valuable. People clearly believed it held important secrets. The real question is, could any of them actually read it? Let's look closer at the text itself. We're talking about 170,000 characters written in an alphabet we've never seen before. It looks a bit like medieval European writing, but it doesn't match anything known. Statistical analysis is where things get weird. The text has all the hallmarks of a real language. Some letters are more common than others. Words have different lengths, and there are patterns that look like grammar. But it also has strange quirks. Certain words repeat way more often than they would in any natural language. If it's a language, it's like nothing else on Earth. If it's a code, it's incredibly sophisticated. And if it's just gibberish, it's the most consistent and well-structured gibberish ever created. The pictures are just as baffling as the words. There's a whole section with over 100 drawings of plants, but none of them are a perfect match for any plant we know. They have impossible features like strange roots or the wrong number of petals. Are they from a lost world or just fantasy? Then there's an astronomical section with zodiac symbols and weird circular diagrams. But the strangest part shows small naked women bathing in a complex network of pools and tubes that almost look like internal organs. The images hint at subjects like herbal medicine, astronomy, maybe even alchemy. They tantalize you with the possibility of meaning, but ultimately they explain nothing. For over a century, the world's best minds have tried to crack this book. Back in the 1920s, one scholar claimed it was Roger Bacon's secret notes in a complex cipher, but his theory was quickly debunked. The legendary codebreakers of World War II gave it a shot and came up empty. In the 1970s, statistical analysis revealed something fascinating. The manuscript seems to have been written by two different people, or maybe one person using two different systems. More recently, researchers have thrown AI at the problem. We've seen theories that it's a form of abbreviated Latin, a lost Proto-Romance language, even Turkish. But none of these theories have stuck. Every proposed solution falls apart under scrutiny, leaving the manuscript's secrets locked away. So what if it's all just a big, elaborate trick? The hoax theory suggests that someone in the 15th century created this beautiful, meaningless book just to sell it to a wealthy collector. And it worked. Emperor Rudolph II supposedly paid a fortune for it. But this theory has its own problems. For one, the text is statistically complex, way more than you'd expect from random scribbling. Second, a lot of care and artistic effort went into it. It doesn't look like a quick fraud. Plus, we know it's genuinely from the 15th century, not a modern fake. And here's the kicker. There are corrections in the margins, as if the author was fixing their own mistakes. Why would you correct nonsense? The hoax theory is possible, but it just doesn't feel right. Another fascinating idea is that it's written in a constructed language, or a conlang. Think of it like Tolkien's Elvish, but created centuries earlier. Scholars in the Middle Ages and Renaissance sometimes invented their own languages for philosophy or to protect secret knowledge. This would explain why the text looks like a language but doesn't match any we know. The big question is, if there was a key or a dictionary for this language, where is it? Maybe it was lost or intentionally destroyed, or maybe the knowledge was only ever passed down orally to a select few. It's a plausible theory that explains a lot, but without finding some other reference to this language, it remains pure speculation. In just the last few years, new claims have popped up. One researcher said it was abbreviated Latin and even offered a partial translation about plants and medicine. But critics pointed out that the translation required a lot of guesswork. Another scholar proposed it was a mix of a Proto-Romance language and medieval Italian, but again the results were inconsistent. AI analysis even suggested the underlying language might be Turkish, but that didn't convince experts either. The problem with all these mud solutions is that they only manage to make a tiny bit of vague sense out of the text, while the rest remains gibberish. A real solution would unlock the entire book, making it all readable. That simply hasn't happened. Given all the plant drawings, many people believe the Voynich manuscript is some kind of medical guide or herbal. Medieval herbals were very common, describing plants and their uses. Maybe this is just one of those, written in a secret code to protect valuable medical recipes. That would make sense, but it still doesn't explain why we can't identify a single plant. Were they from a faraway land? Were they just stylized drawings? Or were they purely imaginary? Medieval medicine was a strange mix of real science, astrology, and theory. If the Voynich is a medical book, it's from a tradition that is so completely lost to time that it's now unrecognizable to us. Today, the Voynich manuscript lives at Yale University's Benecke Library, where it's known as MS-408. The entire book has been digitized and is available online for free, so anyone can try to crack the code. This has created a global community of researchers, both professional and amateur, all trying to solve the puzzle. While the university itself doesn't endorse any single theory, the manuscript's fame continues to grow. It has inspired novels, video games, and all sorts of wild conspiracy theories. Some people claim it's from aliens, or the lost city of Atlantis. But the real mystery is much more profound. We have a genuine 15th century document that has resisted every attempt at understanding. That's amazing enough on its own. The Voynich manuscript reminds us that some things in this world are still truly unknown. So why is this book so incredibly hard to understand? Well, if it's a code, we don't have the key. If it's a lost language, we don't have a dictionary. And at 240 pages, there isn't quite enough text for computers to fully analyze its structure. Unlike the Rosetta Stone, there's no parallel text in a known language to help us out. The illustrations are too ambiguous to provide clear answers. We don't know who wrote it, why they wrote it, or who it was for. Without that context, we're just guessing in the dark. In the end, the Voynich manuscript remains a complete mystery. Is it an elaborate hoax, a coded message, an unknown language, a lost medical text? All theories are still on the table. It may one day be solved with a sudden breakthrough that makes it all clear. Or it may remain a puzzle forever, a humbling reminder that some secrets from the past are simply lost to us. From mysterious books, we now turn to mysterious knowledge. How did ancient cultures gain such a sophisticated understanding of the stars without telescopes or computers? Let's explore the incredible astronomical achievements of our ancestors, who mapped the cosmos using nothing but their own eyes and incredible patience. Ancient peoples observed the night sky with a patience modern civilization has forgotten. Without light pollution, they saw thousands of stars rotating through the seasons. They tracked planets wandering against the stellar background. They predicted eclipses, calculated solstices, and mapped celestial cycles with stunning accuracy. The Babylonians, Mayans, Egyptians, Chinese, and Indians developed sophisticated astronomy thousands of years ago. How did they achieve such precision with naked eyes and simple instruments? What astronomical knowledge did they possess, and how did they acquire it? Let's explore humanity's ancient relationship with the cosmos. The Babylonians, flourishing in Mesopotamia from about 1900 BCE, were perhaps history's first systematic astronomers. They kept detailed records of celestial events for centuries, recording planetary positions, lunar cycles, and eclipses on clay tablets. These observations revealed patterns. The Babylonians discovered the Saros cycle, an 18-year period after which eclipses repeat in similar patterns. This knowledge enabled eclipse predictions centuries in advance. They calculated the lunar month to within seconds of modern measurements and tracked Venus's appearances with precision. They developed mathematical astronomy, using arithmetic to predict planetary positions. Their astronomical tablets, preserved in cuneiform, demonstrate observations spanning generations. Knowledge accumulated as scribes added new observations to old records, creating an astronomical database that spanned centuries. This patient, multi-generational observation is how ancient astronomy achieved its precision, not through instruments but through time and dedication. The Maya of Mesoamerica, flourishing from around 2000 BCE, independently developed their own sophisticated astronomy. They calculated the solar year as 365.242 days, remarkably close to the modern value. They tracked Venus with obsessive precision, knowing its 584-day synodic period accurately. The Dresden Codex, a Mayan book that survived Spanish destruction, contains detailed Venus tables predicting its positions decades ahead. The Maya also calculated the lunar month accurately and predicted eclipses. Their observatories, like El Caracol at Chichen Itza, aligned with key astronomical events. How did they do this? Through patient observation over centuries, mathematical sophistication including the concept of zero, and a cultural prioritization of astronomy for religious and agricultural purposes. Mayan kings even claimed divine authority partly through their astronomical knowledge, creating a political incentive for precision. For the Maya, astronomy wasn't just science, it was power. We've discussed the Antikythera mechanism's mechanical sophistication, but its astronomical knowledge deserves special emphasis. The device modeled the irregular motion of the moon, using epicyclic gearing, representing its elliptical orbit and variable speed. The ancient Greeks understood that the moon doesn't move uniformly, it speeds up and slows down. The mechanism incorporated this knowledge mechanically. It predicted eclipses using the Saros and Metonic cycles and tracked the 5 visible planets. This represents theoretical astronomy, not just observation, but mathematical modeling of celestial mechanics. The Greeks inherited Babylonian observations, added geometric modeling, and created predictive mathematical astronomy. Figures like Hipparchus and Ptolemy developed models of planetary motion that remained standard for over 1,000 years. The Antikythera mechanism embodies this theoretical tradition, translating abstract astronomy into a tangible mechanical form. Its knowledge made physical. Ancient Egyptians developed one of history's first solar calendars around 3000 BCE. They observed that Sirius, the brightest star, appeared on the eastern horizon just before sunrise once a year, an event called the heliacal rising. This occurred near the Nile's annual flood, providing a celestial calendar for agriculture. The Egyptians divided the year into 365 days, close to the actual solar year. They recognized the slight discrepancy, but their civil calendar didn't account for it, causing a slow drift over time. However, they maintained a separate astronomical calendar, tracking Sirius accurately. Egyptian temples also incorporated astronomical alignments. The Abu Simbel Temple, built by Ramesses II, aligns so that twice a year sunlight illuminates the inner statues. The Egyptians even understood precession, the slow wobble of Earth's axis that causes stars' positions to shift over millennia. This knowledge required centuries of observation and record-keeping. We've discussed Stonehenge's solstice alignments, but broader Neolithic British astronomy deserves attention. Across Britain, numerous stone circles and monuments show astronomical alignments, far more than chance would predict. The Callanish stones in Scotland align with lunar cycles and the moon's extreme positions. The Newgrange Passage tomb in Ireland illuminates its inner chamber only at the winter solstice sunrise. These alignments weren't accidental. They required sustained observation and deliberate orientation. But Neolithic peoples had no writing. So how did they maintain this knowledge across generations? Likely through oral tradition, ritual, and the monuments themselves serving as records. The stones encoded knowledge. By returning to these sites during celestial events, communities reinforced their astronomical understanding. The physical monuments became an external memory, preserving knowledge when writing didn't exist. This suggests alternative methods of scientific record-keeping we often overlook. China maintained astronomical records for over 3,000 years, creating one of history's longest continuous scientific traditions. Chinese astronomers meticulously recorded comets, supernovas, sunspots, and eclipses. These records are invaluable to modern astronomy. For example, Chinese observations of a supernova in 1054 CE helped identify the Crab Nebula. Chinese astronomy was state-sponsored. The emperor employed official astronomers whose job was tracking celestial events. Unexpected events like comets or eclipses were interpreted as omens, giving astronomy huge political importance. This incentivized accuracy. The Chinese developed sophisticated instruments, armillary spheres for measuring celestial positions and water-driven clock towers. They calculated the solar year accurately and developed complex calendars. Chinese astronomy combined empirical observation, mathematical calculation, and cosmological theory into a comprehensive system. The continuity of observation across millennia allowed them to recognize patterns impossible to see in shorter timescales. Ancient India developed a highly mathematical form of astronomy. Indian astronomers calculated the solar year as 365.287 days, within minutes of the modern value. Aryabhata, in 499 CE, proposed that Earth rotates daily, explaining the apparent motion of stars, a heliocentric insight centuries before Copernicus became famous for it. Indian astronomers understood that the moon reflects sunlight rather than producing its own. They calculated planetary orbits, predicted eclipses, and understood precession. Their astronomy utilized sophisticated mathematics, including trigonometry and early concepts of calculus. The Surya Siddhanta, an astronomical text possibly dating to 400 CE, contains remarkably accurate values for planetary periods and Earth's dimensions. Indian astronomy influenced Islamic astronomy, which then transmitted it to medieval Europe. This knowledge transfer shows how scientific achievements cross cultural boundaries. During Europe's medieval period, the Islamic civilization preserved and advanced astronomical knowledge. From about 800 CE to 1300 CE, Islamic astronomers translated Greek, Indian, and Persian texts, synthesized their knowledge, and made original discoveries. They built observatories in Baghdad, Damascus, and Samarkand, creating instruments of unprecedented precision. Al-Battani refined astronomical measurements, improving on Ptolemy's work. Al-Sufi compiled star catalogues and made the first recorded observation of a distant galaxy, Andromeda. Ibn al-Haytham studied optics and atmospheric refraction, explaining why stars appear higher in the sky than their actual positions. Islamic astronomers questioned Ptolemy's models, seeking better geometric explanations. This work was transmitted to Europe during the Renaissance, providing the foundation for the Copernican revolution. Islamic astronomy shows that scientific progress continued robustly during periods often called the Dark Ages in Europe. Modern astronomy uses telescopes and computers. Ancient astronomy used naked eyes and simple sighting devices. How did they achieve such precision? First, dark skies without light pollution made thousands of stars visible. Second, the human eye, when trained, can detect minute changes. Third, simple instruments, notched sticks, plumb bobs, water levels, can enable accurate angle measurements. Fourth, and most importantly, time. Observing nightly for years reveals patterns invisible in shorter periods. Fifth, multi-generational observation, children learning from parents, adding observations to accumulated records. And sixth, cultural prioritization made astronomy important enough to dedicate resources to it. Ancient astronomy wasn't limited by technology, but enhanced by dedication and patience. We have superior instruments but shorter attention spans. They had inferior instruments but generational patience. While we understand how ancient astronomy worked generally, specific details remain mysterious. How did Neolithic peoples without writing maintain such precise astronomical knowledge? What observational techniques achieved measurements accurate to mere seconds? How did cultures independently discover similar cycles? Did some knowledge transfer occur, or does patient observation inevitably reveal the same patterns? Why did some civilizations prioritize astronomy while others didn't? We have fragments, surviving texts, aligned monuments, but the complete picture is partially lost. We know what they discovered, but not always precisely how they discovered it. Ancient astronomical knowledge proves that sophisticated science predates modern civilization by millennia. But astronomy isn't the only field where ancient achievements puzzle us. Some ancient technologies, methods of creating materials or chemical processes, are lost despite being widely used in antiquity. Damascus steel, Roman concrete, and Greek fire represent manufacturing techniques once common but now impossible to perfectly replicate. How were they made? And why were these methods lost? Let's explore these lost technologies that worked for centuries and then vanished. Throughout history, civilizations developed incredible technologies, manufacturing processes, materials, chemical techniques that worked reliably for centuries. But then, through cultural collapse, economic change, or other major disruptions, these technologies were lost. The knowledge often died with the last practitioners who never fully documented it. Today, scientists and engineers try to rediscover these methods through experimentation and analysis. Some succeed partially, others remain frustratingly elusive. These lost technologies prove that progress isn't always a straight line, that knowledge can be forgotten, and that ancient craftspeople possessed skills we struggle to replicate. Let's examine three famous examples: Damascus steel, Roman concrete, and Greek fire. Damascus steel, or Wootz steel, was produced between 300 and 1700 CE. It created legendary swords known for exceptional sharpness, flexibility, and a distinctive watery pattern on the blade. These blades could allegedly cut through lesser swords and hold an edge through long battles. The steel came from India and the Middle East, with swords forged in Damascus, giving it its name. Its amazing properties came from its microstructure: carbon nanotubes and carbide nanowires embedded in the iron, creating a material far stronger and more flexible than typical steel. This nanostructure also created the beautiful patterns. But by the 18th century, production stopped. The exact method was lost. Modern metallurgists can analyze surviving blades and see what they're made of, but perfectly replicating the manufacturing process has proven incredibly difficult. What was their original method? And why did it just disappear? What we think we know is that Damascus steel began as Wootz steel ingots from India, made from iron ore with specific trace elements like vanadium. Smiths heated these ingots repeatedly, hammering and folding them to distribute the carbon and impurities evenly, creating a layered structure. The forging temperature, cooling rate, and number of folds were crucial and probably varied between masters. Some researchers believe that plant materials added during forging introduced specific elements that affected the steel's properties. In 2006, researchers discovered that the wavy patterns were created by carbon nanotubes and nanowires. Basically, nanotechnology achieved without modern science. They even recreated similar steel by adding certain chemicals. But ancient smiths used natural ores with an unknown exact composition. Whether modern versions truly match the original remains a hot debate. The ancient process achieved results we struggle to replicate, even with all our modern knowledge. So, why was it lost? Several factors probably contributed. First, the specific Indian ore mines may have run out or become inaccessible due to political changes. No special ore, no special steel. Second, trade routes were disrupted by wars and falling empires, breaking the supply chains. Third, the knowledge was held by craft guilds who trained apprentices orally. They never wrote the full process down. When these guilds collapsed or the masters died without passing on their knowledge, it vanished. Fourth, the Industrial Revolution brought cheaper, mass-produced steel, making expensive handcrafted swords economically unviable. Demand dried up, and finally firearms made swords obsolete in warfare, removing the main reason to maintain the tradition. The loss of Damascus steel shows how specialized knowledge can disappear rapidly when the specific materials, traditions, and economic demand that support it all change at once. Now let's talk about Roman concrete. Structures built with it 2,000 years ago are still standing, while modern concrete can crumble within decades. The Pantheon in Rome, with the world's largest unreinforced concrete dome, is still perfectly intact. Roman harbors submerged in seawater have actually grown stronger over the centuries instead of eroding. How did they do it? The secret was their recipe: lime mortar, volcanic ash, stones, and seawater. That volcanic ash, called pozzolana, was the key. It contains materials that react with lime and seawater in what's called a pozzolanic reaction, creating an incredibly durable binder. Modern concrete uses Portland cement, which has a different chemistry. It's stronger at first, but breaks down much faster, especially in seawater. Roman concrete started weaker but continued to strengthen over centuries as those slow reactions continued. The Romans didn't understand the chemistry. They just discovered through trial and error that certain volcanic ashes made superior concrete. But here's the most amazing part. Recent research reveals that Roman concrete has self-healing properties. When submerged in seawater, the volcanic ash reacts with the water to grow interlocking crystals that fill in any cracks and strengthen the structure over time. Cracks that would destroy modern concrete instead trigger a chemical reaction that repairs Roman concrete. Researchers analyzed samples from Roman harbors and discovered this incredible self-healing mechanism. They found that over 2,000 years, the concrete had continued to get stronger as new minerals formed. So why aren't we recreating it? Well, the right kind of volcanic ash is only found in specific places. Plus, Roman concrete takes a long time to reach its full strength, and modern construction demands speed. Some engineers are now adding volcanic ash to concrete for marine structures, trying to recapture that ancient durability. So if Roman concrete was so good, why don't we use it today? First, it requires specific volcanic ash that isn't available everywhere, while Portland cement can be made from common limestone and clay. Second, Roman concrete is weaker initially. Modern construction demands immediate strength. Third, while great for massive structures and marine environments, it isn't ideal for all modern uses, especially those with steel reinforcement. And fourth, modern construction economics prioritize speed and initial cost over century-long durability. A building designed to last 50 years uses cheaper concrete than one meant to last for centuries. It's not that the technology is truly lost, we understand it, but a combination of practical, economic, and material factors make it unsuitable for most modern applications, despite its incredible durability. Next up, Greek fire. This was an incendiary weapon used by the Byzantine Empire starting in the 7th century. It was a liquid that would ignite on contact with water, burn fiercely even on the water's surface, and was nearly impossible to put out. In fact, water just made it burn more intensely. The Byzantine navy used it with devastating effect, projecting it through bronze tubes mounted on their ships. The formula was guarded as a top state secret, and it gave them a crucial military advantage for centuries. But by the 13th century, its use declined and eventually stopped. The exact formula was lost. We have numerous historical accounts describing it, but we can't replicate it precisely. So what was Greek fire, and why was the formula lost? These questions remain a mystery. Modern researchers have a few ideas about what Greek fire might have been made of. Likely ingredients include petroleum, pine resin, sulfur, quicklime, and maybe saltpeter. The fact that it ignited with water strongly suggests quicklime, which produces a lot of heat when wet, potentially igniting the other flammable components. Scientists have tried various recipes, and they can create mixtures with similar properties. However, no modern recreation perfectly matches all the historical descriptions: burning on water, being projected through tubes, and being nearly impossible to extinguish. It's possible some of the ancient accounts were exaggerated, or we might be missing a crucial ingredient or preparation method. It was also likely a family of related formulas, not just one single recipe. This complexity makes an exact recreation nearly impossible without more specific information. So, Why did Greek fire disappear? It was a state secret known to only a very few people, a strategy to prevent enemies from getting it. This extreme secrecy meant that if something happened to those few, the knowledge was gone. The formula was likely transmitted orally, or in classified documents that didn't survive the Byzantine Empire's decline. As the empire collapsed, the state apparatus that protected the secret broke down. At the same time, new gunpowder weapons eventually surpassed Greek fire's effectiveness. Finally, when Constantinople fell in 1453, any remaining knowledge holders were likely killed or scattered. This combination of intense secrecy, political collapse, and technological change effectively destroyed the knowledge forever. Greek fire is a perfect example of how even the most successful state secrets can be permanently lost when the state itself collapses. Damascus steel, Roman concrete, and Greek fire are famous, but many other technologies have been lost. The incredible sound quality of Stradivarius violins from the 17th and 18th centuries is something modern makers struggle to match, despite intense analysis of the wood and varnish. The construction techniques used for medieval cathedrals, especially their flying buttresses and rose windows, required knowledge that has been partially lost. These examples share common themes: craft knowledge passed down orally through guilds or families, disruptions that broke that chain of transmission, and modern attempts at recreation that are only partially successful. Lost technologies remind us that knowledge isn't automatically preserved. It requires active transmission and favorable conditions to survive. So, what do these lost technologies teach us? First, knowledge is fragile, especially practical skills passed on by word of mouth. Second, stable economies and societies are essential for preserving specialized skills. Third, progress isn't a one-way street. Societies can lose capabilities they once had. Fourth, modern isn't always better. Sometimes ancient solutions were superior for their specific purpose. And analyzing these ancient technologies can inspire modern innovation, from nanomaterials to marine construction. Finally, it teaches us some humility. Our ancestors weren't primitive, they were often highly sophisticated. Lost technologies prove that human ingenuity is timeless, that knowledge must be actively preserved, and that the past still has powerful lessons for the present. From these lost manufacturing methods, we now turn to puzzling physical objects, artifacts that seem completely out of place in their historical contexts or whose purposes remain a total mystery. These out-of-place artifacts, or parts, challenge our understanding of ancient capabilities. Some have simple explanations, but others remain genuinely puzzling. We'll examine several famous examples, separating legitimate mysteries from misinterpretations, and exploring what these objects reveal about ancient peoples and our own assumptions about them. Out-of-place artifacts, objects that seem anachronistic, too advanced for their supposed age, or whose purposes mystify experts. The term part is popular in fringe archaeology, often applied to objects claimed as evidence of ancient aliens or lost civilizations. We'll avoid such speculations, focusing instead on genuinely puzzling artifacts recognized by mainstream archaeology as mysterious or debated. Some artifacts challenge our timelines, others demonstrate unexpected technological capabilities. A few remain completely unexplained. Each one reveals that ancient peoples were more capable and creative than we often assume. Let us examine history's most intriguing unexplained objects. The Baghdad Battery, discovered in 1936 near Baghdad, Iraq, consists of a ceramic jar containing a copper cylinder with an iron rod inside. Dating to the Parthian period, around 200 BCE to 200 CE, the object resembles a primitive battery. When filled with an acidic liquid like vinegar, it could theoretically generate a low voltage. This raises an intriguing question. Did ancient Mesopotamians discover electricity? Replications show the device can produce about 1 volt, possibly useful for electroplating gold onto silver. However, most archaeologists are skeptical. The objects might simply be storage jars for scrolls. No ancient texts describe electricity, and no other similar objects have been found. The Baghdad Battery remains disputed, a possible electrochemical cell or a coincidental configuration. The mystery persists not because it's impossible, but because we lack the context to know its actual use. The Piri Reis map, created in 1513 by Ottoman Admiral Piri Reis, shows the Atlantic coastlines of Europe, Africa, and remarkably, South America. The map is a fragment, but it shows surprising accuracy for its time. Piri Reis noted that he compiled it from about 20 older maps, including some captured from Christopher Columbus. The real mystery involves the supposed depiction of Antarctica's coastline as it appears beneath the ice. However, this interpretation is highly controversial. Most cartographers argue the southern portion is just an extended South American coast, or a theoretical landmass. The coastline's apparent accuracy might just be a coincidence. Piri Reis certainly had access to recent Portuguese and Spanish exploration data, explaining much of the map's accuracy. So, while the map is a remarkable feat of compiling knowledge, it doesn't prove ancient civilizations were mapping Antarctica. The Dropa stones are allegedly stone discs discovered in Chinese mountains in 1938, bearing spiral grooves with tiny hieroglyphics. Proponents claim these discs are 10,000 years old and describe extraterrestrial visitors. This story is a classic in ancient astronaut literature. However, the Dropa stones are almost certainly a hoax. There's no verified archaeological evidence they exist. No reputable museum holds them. Photos that claim to show the Dropa stones actually depict ancient Chinese Bai discs, real ceremonial jade objects with no mysterious inscriptions. The story emerged from a single dubious source and has been repeatedly debunked. The Dropa stones are a cautionary tale. Not every mystery is genuine. Some are just fabrications that take on a life of their own. We've already talked about the Antikythera mechanism, but it's worth mentioning again as perhaps the most legitimate, out-of-place artifact. Unlike many dubious examples, the Antikythera mechanism is real, well documented, and genuinely sophisticated beyond all expectations for its era. It represents technology that, according to our previous understanding, simply shouldn't exist. This establishes an important principle. Genuine OO parts exist. Ancient people did occasionally achieve technological feats we didn't expect. The Antikythera mechanism isn't evidence of aliens or time travelers, it's evidence of human ingenuity and how easily knowledge can be lost. It proves that our assumptions about ancient capabilities are sometimes wrong, and it sets the standard for evaluating other potential OO parts. They must have physical evidence, archaeological context, and be studied scientifically. The Saqqara bird, discovered in an Egyptian tomb in 1898, is a wooden object from around 200 BCE. It resembles a bird with outstretched wings and has been interpreted by some as a model airplane, suggesting the Egyptians understood aerodynamics. However, most Egyptologists identify it as a bird figurine or perhaps a weather vane. While it has wings, it lacks a tail for stability. Experiments with replicas show that without a tail, it doesn't glide well. Adding one improves its performance, but there's no evidence it ever had one. The Saqqara bird most likely represents a falcon, sacred to the god Horus. The airplane theory is a classic case of seeing modern concepts in ancient objects. Context is key. Not everything that looks like modern tech was ancient tech. In 1961, rock collectors in California found what looked like a spark plug inside a geode, supposedly 500,000 years old. This would be impossible. Spark plugs are a modern invention. The Kozo artifact became famous as evidence of an advanced ancient civilization or time travel. The truth, however, is far less sensational. The object wasn't in a geode, but a concretion, a mineral formation that can encase objects very quickly. X-rays showed it was a 1920s champion spark plug. Concretions can form in decades, not millennia. The collectors simply misidentified the rock. This case shows how simple mistakes and sensationalism can create false mysteries. Proper scientific analysis solved this one easily. The Phaistos disc, discovered in 1908 on Crete, is a fired clay disc from around 1700 BCE. Both sides are covered in a spiral of stamped symbols. There are 241 impressions made from 45 distinct signs, representing one of history's earliest uses of movable type. The script is unknown and has never been deciphered. Some have questioned its authenticity, but most archaeologists accept it as a genuine Minoan artifact. Countless decipherment attempts have been proposed, but none are widely accepted. It might be a religious text, an administrative document, or something else entirely. Its purpose and meaning remain a complete mystery. Unlike texts with more content, the Phaistos disc's brevity makes it incredibly difficult to crack. It's a true archaeological enigma. In Costa Rica, there are over 300 nearly perfect stone spheres, ranging from a few centimeters to over 2 meters in diameter. The largest weigh over 15 tons. They were created by the Damascus culture between 500 and 1500 CE. The spheres are remarkably round. How were they made with just stone tools? The Damascus people likely shaped the hard granodiorite rock with hammerstones, then refined them by pecking, grinding, and polishing. It's possible, but would have been extraordinarily time-consuming. Why create them? We don't know. They might mark important sites or represent cosmological ideas. Unfortunately, many were moved by fruit companies in the early 20th century to be used as lawn ornaments, destroying their original archaeological context. They are mysterious primarily because their context was lost before they could be properly studied. In 1973, workers in Romania allegedly found an aluminum wedge alongside mastodon bones in deposits supposedly 2 million years old. This would be impossible, as aluminum wasn't isolated until 1825. But there are problems with this story. The object's discovery is poorly documented. Its composition suggests a modern alloy. The dating is uncertain. Just because it was found near mastodon bones doesn't mean it's the same age. The most likely explanation is that it's a modern piece of aluminum, perhaps a tool part, that was lost and later found in the excavation. This case highlights the importance of provenance, the secure documentation of an object's discovery. Without it, objects can be easily misidentified. The aluminum wedge of Ayud is almost certainly a modern object, not an ancient mystery. So evaluating OOPArts requires us to distinguish genuine mysteries from misidentifications and hoaxes. Genuine archaeological mysteries, like the Antikythera mechanism and the Phaistos disc, have physical objects that can be studied, secure origins, and are recognized as unexplained by mainstream experts. Many popular OOPArts fail this test. Common problems include insecure provenance, misidentification of ordinary objects, and outright hoaxes. Responsible investigation requires skepticism and scientific analysis. Extraordinary claims require extraordinary evidence. Ancient people were incredibly creative, but they weren't building airplanes or batteries. Their real achievements are remarkable enough without inventing false ones. When they are genuine, unexplained artifacts teach us valuable lessons. They challenge our assumptions about ancient capabilities and reveal gaps in our historical understanding. They show us unexpected technological sophistication, expanding our appreciation for ancient ingenuity. But they also teach us caution. Not everything that seems mysterious is genuinely unexplained. Sometimes we just lack context, and sometimes we're being deceived. The lesson is to remain open-minded but critical. We must respect the past by acknowledging what we don't know, while honestly evaluating what we think we know. From mysterious objects, we now turn to mysterious disappearances, civilizations that flourished then vanished. The classic Maya, the Indus Valley civilization, the Minoans and others collapsed or dispersed, their great cities abandoned. What causes entire civilizations to fail? Can we learn from these ancient collapses? As we examine these vanished societies, we confront questions that are deeply relevant to our own civilization's future. Join us as we explore history's vanished civilizations and the mysteries surrounding their ends. Throughout history, complex civilizations have risen, flourished for centuries and then vanished, their cities abandoned and their knowledge lost. Sometimes we know why: conquest, disease, or environmental change. Other times, the reasons remain shrouded in mystery, a complex tangle of factors we can only glimpse through fragments of evidence. But these weren't failed societies. They were successful for centuries before facing challenges they couldn't overcome. By studying their downfall, we learn about the fragility and resilience of human society itself. Let's explore some of these lost worlds and the puzzles they left behind. The classic Maya civilization thrived in Mesoamerica for over 700 years, building magnificent cities and developing sophisticated writing and mathematics. Then, between 800 and 900 CE, the southern Maya cities were systematically abandoned. The population plummeted, construction halted, the jungle reclaimed what was once a bustling civilization. Now, this wasn't a total extinction. Maya descendants live on today, but it was a catastrophic collapse. What happened? Theories range from prolonged drought and intense warfare to deforestation and political unrest. Recent climate data points to a severe multi-decade drought, which would have crippled their corn-based agriculture. But drought alone probably wasn't the culprit. More likely, it triggered a domino effect. Crop failure led to famine. Famine sparked social chaos, and the entire system unraveled. It's a stark reminder of how vulnerable complex societies can be to multiple stresses at once. Next, let's journey to the Indus Valley, in modern-day Pakistan and India. From around 3300 BCE, this civilization, also known as the Harappan, was one of the world's largest. They were master urban planners, with grid layouts, advanced drainage systems, and trade networks reaching as far as Mesopotamia. Then, around 1900 BCE, a slow decline began. Cities were gradually abandoned, their script fell into disuse. We still can't fully decipher it today. By 1300 BCE, the urban culture was gone. The suspects? Climate change, a shifting Indus River, epidemics, or even invasion. Current research suggests changes in the river system, combined with a drier climate, made city life unsustainable. Unlike the sudden Maya collapse, the Indus decline was a gradual process over centuries, suggesting environmental stress rather than a single catastrophic event. The people likely dispersed, their legacy woven into the fabric of later cultures, but their great urban civilization vanished. Now to the island of Crete and the Minoan civilization, which flourished from 2700 BCE. They were Europe's first literate society, known for their grand palaces, stunning art, and maritime trade. Around 1600 BCE, the nearby volcanic island of Thera erupted in one of history's most violent explosions. It triggered massive tsunamis and may have altered the global climate. So, did this eruption destroy the Minoans? The timing is suspicious, and it certainly hit Crete hard. However, the Minoan civilization survived for another 2 centuries before its final collapse, which coincides with a conquest by the Mycenaean Greeks. The mystery is how these events connect. Did the eruption weaken the Minoans just enough for the Mycenaeans to take over? Or was it all a tragic coincidence? The Minoan story shows us that natural disasters can be a catalyst for collapse, but rarely are they the sole cause. Around 1200 BCE, a widespread catastrophe struck the ancient world. In just 50 years, most of the great Bronze Age civilizations of the Eastern Mediterranean and Near East either collapsed or were severely weakened. The Hittite Empire, Mycenaean Greece, and numerous city-states all fell. Cities were burned, populations declined, writing systems were lost, and trade networks vanished. This event, known as the Bronze Age collapse, plunged the region into a centuries-long dark age. What could cause such a coordinated disaster? Theories point to migrations of mysterious sea peoples, a storm of earthquakes, or widespread drought and famine. Another compelling idea is a systems collapse. These civilizations were so interconnected through trade that when one part of the network failed, it triggered a devastating chain reaction. The Bronze Age collapse is a powerful lesson in how interdependent civilizations can fall together, each one's problems amplifying the others. In the American Southwest, the ancestral Pueblones built incredible cliff dwellings and multi-story pueblos between 700 and 1300 CE. Chaco Canyon in New Mexico was a major hub, a center of sophisticated architecture and trade. Then, in the 13th century, these major sites were abandoned. The people migrated, becoming the ancestors of modern Pueblo peoples. The primary culprit appears to be the Great Drought, a brutal 23-year dry spell that made farming nearly impossible. Tree ring data confirms it. But that's not the whole story. Violence was on the rise, likely due to competition for scarce resources. Trade networks broke down and political structures fragmented. Modern Pueblo peoples also speak of religious reasons for the migration. It's another case where environmental stress combined with social pressures to end a successful way of life. The people themselves didn't vanish. They adapted by moving to areas with more reliable water. Let's head north to Greenland. Around 985 CE, Norse settlers established colonies that survived for nearly 500 years. At their peak, about 5,000 Norse lived there, raising livestock and trading walrus ivory with Europe. Then, sometime in the 15th century, they disappeared. When Europeans returned, only the Inuit remained. What happened to the Norse? It was a perfect storm of factors. The climate cooled during the Little Ice Age, making farming harder. The ivory trade dried up. The Norse were culturally rigid, refusing to adopt the superior survival techniques of the Inuit, like seal hunting. They became more and more isolated from Europe. Archaeological evidence shows the last generations suffered from severe malnutrition. They likely didn't all die in Greenland, but slowly abandoned the settlements, heading back to Iceland or Europe. Their story is a chilling example of how climate change, economic shifts, and a refusal to adapt can doom a society. Angkor, the capital of the Khmer Empire in Cambodia, was one of the largest pre-industrial cities on Earth. From the 9th to the 15th centuries, it supported up to 750,000 people with an incredibly sophisticated water management system of reservoirs and canals. But in the 14th and 15th centuries, Angkor declined and was gradually abandoned. Research suggests the climate became erratic, with severe droughts followed by devastating floods, overwhelming the water system designed for stability. At the same time, maritime trade was booming, making coastal cities more attractive than inland Angkor. So the Khmer didn't disappear. They simply moved their capital closer to the coast. Angkor's abandonment was more of a strategic relocation than a total collapse, but it left behind the magnificent jungle-clad ruins that captivate us today. Far out in the Pacific lies Easter Island, or Rapa Nui. Settled by Polynesians, this society is famous for carving nearly 900 massive stone statues, the Moai. At its peak, the population may have reached 15,000. But when Europeans arrived in 1722, they found only a few thousand people and a culture in decline. The classic story is one of ecocide, that the islanders cut down all their trees to transport statues, leading to environmental collapse and societal breakdown. But recent research shows it's more complicated. The forest was already disappearing before Moai building peaked, partly thanks to rats eating the tree seeds. Then came European contact, bringing devastating diseases and slave raids that decimated the remaining population. While environmental stress was a factor, the story of Rapa Nui is a complex tragedy of internal pressures and brutal external forces. Back in North America, near modern-day St. Louis, stood the city of Cahokia. Between 900 and 1300 CE, it was the largest pre-Columbian city north of Mexico, home to tens of thousands of people, more than London at the time. It featured massive earthen mounds and extensive trade networks. But by 1400 CE, the city was completely deserted. Why? Theories include environmental damage from deforestation and overhunting, massive floods from the nearby Mississippi River, climate change, disease, and political instability. Recent evidence suggests that violence increased just before the abandonment, pointing to social conflict. Without any written records from the inhabitants themselves, Cahokia's collapse remains one of North America's greatest archaeological mysteries. We see the evidence of its fall, but have to infer the story. As we look back at these fallen societies, common patterns emerge. Environmental stress, drought, floods, climate change is a recurring theme, but it rarely acts alone. It's often compounded by social factors like inequality and conflict, and economic problems like the disruption of trade. Complex societies are like intricate machines. One problem can trigger a cascade of failures. But collapse isn't inevitable. Some societies adapted and survived. The key was flexibility, effective leadership, and sometimes just good luck. The lesson isn't that civilizations are doomed to fail, but that they are fragile systems that require constant adaptation and care. Collapse is a process, not a single event. So why study these ancient collapses? Because the challenges they faced, climate change, resource depletion, inequality, are still with us, but now on a global scale. Their stories teach us that environmental degradation has consequences, that unsustainable practices can't last forever, and that even the most successful civilizations are not immune to collapse. But we have advantages they lacked: global communication, scientific knowledge, and the ability to learn from history. Ancient collapses are not prophecies of our future, but they are warnings we should heed. Understanding why they failed can help us avoid making the same mistakes. From collapsed civilizations, we approach our journey's end. We've explored mysteries from the world's oldest temple to vanished peoples, from precise megaliths to lost technologies. Each one reveals something profound about human ingenuity, the fragility of knowledge, and the vast gaps in our understanding of the past. As we conclude, let's reflect on what these ancient mysteries teach us about history, about science, and ultimately, about ourselves and the future we are building. We've journeyed together through mysteries that span millennia and continents, examining structures that defy easy explanation and technologies lost to time. We've seen civilizations that vanished, leaving only questions behind. Some of these puzzles have partial solutions, others remain completely unexplained. But they all share one powerful quality: they humble our assumptions about the past and challenge our understanding of human achievement. These ancient mysteries are a profound reminder that our knowledge has limits. Despite all our advanced technology, we can't answer every question. Evidence is often fragmentary. Time destroys so much, and entire oral traditions have died out without ever being documented. It's a humbling but important realization. Acknowledging our own ignorance isn't failure, it's the very first step toward wisdom. It's tempting to fill these gaps with easy speculation, but the real intellectual honesty lies in accepting that some things are simply unknown, and that's okay. What these mysteries also show us, without a doubt, is that ancient peoples were not primitive. They had the same brain capacity we do. Given time, resources, and motivation, they achieved truly remarkable things. Think of Göbekli Tepe's precision, the staggering scale of the pyramids, or the sophistication of the Antikythera mechanism. These weren't anomalies or alien handiwork, they were human achievement, pure and simple. We often underestimate them, but their skills in architecture, astronomy, and engineering are a testament to the fact that humanity has always been ingenious, creative, and adaptable. These mysteries aren't evidence of lost super-civilizations, they are evidence of human potential. They also teach us a sobering lesson: knowledge is fragile. The recipe for Damascus steel was lost. The formula for Greek fire vanished. The techniques for Roman concrete were forgotten for centuries. These losses weren't inevitable. They happened because of war, social disruption, and conquest. Knowledge requires active transmission and stable societies to survive. It can disappear in a single generation. Today, our knowledge is stored differently, digitally, but it's still vulnerable. This ancient lesson reminds us not to take what we know for granted. We must actively preserve and share it, but there is so much value in what we don't know. Mystery drives curiosity. It motivates research and reminds us that our world holds depths we haven't yet fathomed. In an age of instant answers, an unsolvable mystery is precious. It teaches patience, humility, and creativity. Science itself thrives on mystery. Every solved problem just makes way for a new, more interesting question. The inquiry never ends, and that sense of wonder is a renewable resource. Of course, where there's mystery, pseudoscience often follows. Ancient aliens, magical explanations for Atlantis. These ideas are popular, but they're harmful. They disrespect ancient peoples by crediting their achievements to outside intervention, and they mislead our understanding of science. The real mysteries, like the purpose of Göbekli Tepe or the contents of the Voynich manuscript, are fascinating enough without fabricating new ones. Responsible inquiry means sticking to the evidence, being honest about uncertainty, and applying critical thinking. The truth is always more interesting than fiction. In the end, these ancient mysteries reveal as much about us as they do about the past. They act like mirrors. When we call an ancient achievement impossible, we reveal our own underestimation of their capabilities. When we invoke aliens, we reveal our discomfort with uncertainty. Studying these mysteries requires us to study ourselves, our biases, our blind spots, and our cultural conditioning. History isn't just about understanding the past, it's about understanding how we understand the past. The lessons these mysteries hold are directly applicable to our future. From collapsed civilizations, we learn about environmental stress and the risks of short-term thinking. From lost technologies, we learn to document our knowledge. From their incredible achievements, we learn that patience and dedication can produce remarkable results. The past is a laboratory, offering a guide for navigating our own uncertain future. And through it all, there is the sheer joy of discovery. The thrill of finding a new site, translating an ancient text, or finally understanding a lost technology is what drives researchers forward. And that joy is for everyone. Whether you're a professional archaeologist or just someone curious about the past, you are part of this grand collaborative investigation. The joy comes from the process itself, asking good questions, following the evidence, and appreciating both what we know and what we don't. Ultimately, studying ancient mysteries is about respecting the people who lived in the past. They weren't characters in a story. They were human beings with hopes and fears just like ours. When we study their achievements, we honor their humanity. When we preserve their sites, we protect their legacy. They deserve to be recognized as fully capable and worthy of study on their own terms. This journey of discovery is far from over. New technologies are revealing hidden structures and clarifying ancient histories every single day. The next generation of researchers will solve mysteries we can't even dream of solving. We aren't at the end of the journey. We're just at a way station, adding our small contribution to an understanding that began with the very first humans who looked up at the stars and wondered. So why do we care so deeply about the distant past? Because curiosity is part of our nature. Because connecting with our ancestors helps us understand who we are. Because wonder enriches our lives. We study ancient mysteries because doing so makes us more fully human. It connects us to our species' grand story and reminds us that our existence is miraculous, mysterious, and deeply meaningful. Take a deep breath. The atoms in your lungs once circulated through ancient Egyptians, Mayan astronomers, and Greek inventors. We are connected through the literal substance of our existence. Their mysteries are our mysteries. Their achievements are our achievements. Every breath connects you to this incredible human story. You are part of that story, and that is the real mystery and the real wonder. Thank you so much for joining me on this incredible journey. The mysteries remain, the wonder persists, and the questions echo through time. If you enjoyed this exploration, please consider liking this video and subscribing for more journeys into the past. Rest well and never stop wondering.